Well, the purpose of our mission here at Aquarius Reef Base is to look at some problems associated with the emerging problem of ocean acidification. We've been adding a lot more CO2 to the atmosphere in recent years, fossil fuel burning, land use change, cement manufacturing. There's lots of different ways in which we've added a lot more CO2. That CO2 isn't just staying in the atmosphere. A large fraction of it, something a little around 50% of it, moves into the oceans. As it moves into the oceans, it reacts with the water to make carbonic acid, H2CO3. So what we're seeing as a result of that carbonic acid increase is the same thing that happens to you if you eat too much rich food. You create an acid stomach. So what's happening here is that the sea has an acid stomach, and the problem that we're beginning to face is that coral reefs, which are made of a carbonate mineral, act like tums. In other words, there's concern about coral reefs being damaged by this increased acid that's in the ocean. So we're here to try to look at the effects of global ocean acidification as compared to local ocean acidification. There's two processes by and large that are going on. One is the global CO2 that's coming into the ocean from the atmosphere. Again, the stuff that we're putting up from fossil fuel burning. But there's also a lot of CO2 input from local respiration processes. Animals like us take in oxygen, respire, and pump out CO2. That's also happening out on the reef. One of the problems in dealing with local acidification by reef organisms and stuff is being able to be out there and to make observations in nature with all the variables that occur naturally. And so we've had to evolve a series of instruments in order to deal with 24-hour, 24/7 measurements. And you're looking at some of them right now. In fact, there's something very exciting going on with one of our instruments out on Conch Reef, out at the Aquarius Reef Base on Conch Reef. Screen here, probably too small to see, is showing me something very exciting. One of our instruments is showing that as one of the big sponges out there that's pumping out CO2 locally, it's going through a little hypoxic event. It's hyperventilating. It's taking in a lot of oxygen and not release and using a lot of that oxygen. And in so doing, it's also producing a lot of other chemistry that's very interesting to us. So we're observing this live only because of the new technologies that we've been able to implement during our mission because of the facilities that are located out on Conch Reef 4 miles offshore. So each one of these instruments that you're seeing on this desk are doing in situ observations, and they're among the only instruments in the world that can now do this. This first one is measuring oxygen concentrations out on the reef, and it's the respiration that we're talking about. This bigger computer screen is showing you data from one of the world's first in situ underwater mass spectrometers. It's a membrane inlet mass spectrometer that's capable of measuring anything that's volatile in seawater that can dissolve across a membrane, diffuse across a membrane, and enter into the mass spectrometry gear. So we're literally watching all the gases, oxygen, nitrogen, argon, CO2, live with this computer. So you're looking at live data from Conch Reef right now. This technology has just evolved. We've got one of the 3 instruments in the world of this type, designed by Monitor Instruments Company here. This next computer over here is showing live nitrate data, and it's also a unique instrument built and designed at the University of South Florida. This instrument measures every 5 seconds a form of dissolved nitrogen, nitrate. Nitrate is a very important nutrient out on the reef. Too much of it, the coral reef is quite unhappy. It wants to have low nutrient conditions. And so we're able to now, with this new kind of instrumentation, make live measurements 24/7. We expect to run this instrument continuously for the 2 weeks, just like the mass spectrometer and other instruments that you're seeing on the table. This last one on the right we just put in this morning. In fact, we just put in the mass spectrometer and this one on the right this morning. This is another instrument that's actually going to measure chemical differences between water next to the seafloor and water back up in the water column, 5 meters above the bottom. What we're looking to do is differentiate between CO2 that's coming in from the atmosphere, the fossil fuel CO2 that I mentioned before, versus CO2 that's being generated right on the seafloor by all the animals Many of you probably know that our coral reefs are in trouble. The coral cover on reefs around the world has declined from about something greater than 50% to something less than 20% in just a few decades. There's great concern over this, and why that's occurring could be due to a lot of different variables. Global warming, everybody's heard about; pollution, sedimentation. We've also got disease vectors that are heading around that are very difficult to study and pinpoint the source of. And now on top of all those, we've got ocean acidification. So our particular mission here, using these instruments that you see on the bench, is to deal with ocean acidification, how much of it is due to the global CO2 additions that we're all part of, and how much of it is due to local benthic respiration right down there on the seafloor.